Hey everyone, it's time to take a look at LLDP in the confines of diagnostics. Now, what I have is I have a wire trace where I've gone in and I've used Wireshark to be able to capture information about all of the stuff that's taking place on one of the links in our virtualized environment. And that's going to be the virtualized environment that's running on R10. Remember, R10 is connected to Cat1. Now, what I'm going to do is I've just brought up the capture for that interface, and you can see we've got a lot of stuff. And again, what I want to do is I want to make certain that we illustrate the fact that we know that we can sort this based on our different filter criteria. So before we used CDP, and we were able to look at the CDP packets. Now, what I want to do right now is I want to look at LLDP frames going across this link, LLDP, and then we press enter, and now we can see here that we have a number of them. So let's take a look at it, and just so that we can walk through this entire process. So as you see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 packets, or 10 frames. So let's take a look at the first one. Now notice it says the source address. Now we already know, per our CDP discussions, that the MAC address of R10 is going to end in OA00. Now when we look at this, and we look at exactly what's going on, notice the destination tells me it's going to an LLDP multicast address. Now that means it's making reference to an LLDP multicast layer 2 address. And again, it's going to be link local, just like in CDP. It tells me my protocol name and it gives me the information. Although notice in here, the information is telling me about that MAC address and the port number and the TTL, where in the confines of CDP, it gave me the host name. It said like R1. It also communicated the MAC address information. So let's pull back the layers and take a look at it. What exactly is taking place in the link layer discovery protocol header information? Now, looking at this, we can see things that are abundantly clear. There's the MAC address. We have the interface name, Ethernet 00, that we're using to connect to Cat1, and that's where I'm currently running the process. We have the 120 seconds, and we also get the system name, R10. However, all I'm pointing out here is in the info, it's not abundantly clear like it was in CDP. CDP put it right up there at the very first of the list. Also looking at this, I want to highlight the fact that we're learning about our operational information, like for instance the iOS that we're running, but notice it says that it's truncated. Truncated simply means that we're only taking a portion of it, we're not taking all of the information. There was no truncation warning in the confines of CDP. Again, just underlying one of the operational differences between LLDP and CDP with regard to its function. Our port description is going to be the Ethernet 00 that we're using, and this notion of capabilities. When I go down and click the down arrow here, what we're going to see is the capability information. Here's the capabilities, but that's just the TLV information, the type link value. What I want to highlight is the actual capabilities that are being communicated. Very similar to what we saw in CDP. Notice it's telling me that it's not a repeater. It's telling me that it is functioning as a bridge. That's what that B was in my show command. Coming down, is it a wireless access point? No. Is it a router? Yes. That's what the R was. So it was B and R. It was acting as a bridge and as a router. Now as we go down, notice everything else is turned off. And the last thing I want to highlight here is, again, we see Layer 3 information with regard to our management IP addresses. And it even tells me specifically that it is an IPv4 address. So it's important to note that LLDP also incorporates IPv6 TLV functionality just like CDP does. Also, one of the really cool things here is that we have the end of frame. Because remember, with the TLVs, we can have frames of varying size to be able to communicate X amount of information. So it's going to be really important for us to be able to have some way of denoting to the system that we are at the end of an individual frame, therefore we're cusping the information that we're exchanging between devices. All right, so I mean that's basically the fundamental components, but there's one other thing that I want to highlight, and that's going to require me to roll all the way back up here to the top. And what I want to do right now is I want to look at the Ethernet headers, because I want to look at those MAC addresses again. Notice, just like with CDP, we have the MAC address, and that MAC address is the MAC address that is burned in on the interface that is used as the source. So again, in our instance for R10, it's going to be 0A00. Now, looking also, remember we had that specialized MAC address that we used for CDP. Well, LLDP has its own MAC address. That MAC address is going to be, as we see here, 0180 C20000E. Now that address tells me and tells the system that this is going to be a LLDP multicast, and it's a well-known LLDP multicast for the IEEE standard LLDP Layer 2 discovery protocol that we've spent just the last couple of minutes talking about. So with that being said, that concludes this conversation about LLDP. We're going to move on to some of our other Layer 2 efficiency mechanisms and tools, and we're going to learn a little bit more about how our MAC addresses are going to first be discovered through ARP and then recorded inside the confines of our content addressable memory, or our CAM tables, that are known colloquially as our MAC address tables. I'll see you guys in that video. Bye-bye.